Unit 2, Day 7, and notice there's no A or B here because this is just one day, so we're going to get it all done in one shot here. So first thing, I can solve rational equations. We did a ton of this in Algebra 2, and I can solve applications of rational equations by hand or by using a graphing calculator. First off, let's do a little bit of review of doing some operations with rational expressions. So here, like this is as rational as it gets with just numbers, no variables involved. 2/3 plus 1/5 is something you probably did in middle school at some point, maybe in like 5th grade or however early they teach it now. But so first off, think what is the least common multiple of the denominators? So what's the least common multiple of 3 and 5? And that would be 15. So what you're going to do is you're going to take everything times 15. Okay, so the first one, and I'm about to distribute that, so it's going to be 2/3 times 15 plus 1/5 times 15. And I'm writing a lot more than you probably do some of this in your head. You wouldn't necessarily need to do all this, and especially if these two are prime, 3 and 5 are prime, you could actually just take 5 times 3 and 3 times 1, and then that'd be all over 3 times 5, because 15 is the least common multiple. So you could do it faster, but I'm just showing every step. That way when we get to these kind of problems up here, and eventually these over here, that makes a whole lot more sense. Okay, so do some reducing here. So 3 and 5, so 15 would be 5, so that's going to be 10. But this is over 15, because the least common multiple is 15 on this one. Here I got the 15 and the 5, that'd be a 3, so that's going to be a 3 on top, but it's over 15 now, because your bottom is still, the least common multiple is 15. And then add those together, you get 13/15. Okay? So this is how this right here, this was just refining the numerators. The least common multiple was 15, so they're over 15. Okay, like over here, my answer, the least common multiple of A and B is going to be AB, A times B. So now I'm going to try to find those numerators. So I'm going to multiply 2 over A times AB plus 3 over B times AB. And notice here the A's cancel, so I have 2B. Here the B's cancel, so I have 3A. Okay, again, A and B are prime to each other, so their product would be AB, and then take B times 2 and A times 3, and that's your kind of fast way of doing it. When you get to a binomial like this, now A and A minus 1, they share no factors. Okay, they don't share any factors, so the least common multiple is just going to be their product. If they share factors, that's a different story, but these don't share any factors. So my answer is going to be over A times A minus 1. And if I multiply by A times A minus 1 over here, the A will cancel, and I'll just have A minus 1. It's supposed to be a minus in there. And then over here, if I multiply by A times A minus 1, A minus 1s would cancel, and I just multiply by A. So I get 2A minus 1 plus 3A. Do some distributing on top here, so 2A minus 2 plus 3A. Okay, on bottom is still A minus 1. You could multiply that out if you want, have A squared minus A. I'm going to leave it factored for now because maybe we can cancel something later. So 2A plus 3A is 5A minus 2. And leave this factored because if there's anything on top that could factor out, you may be able to do some canceling. This one does not do that, so that is your answer. Okay? Now there are two methods you can use here for solving rational equations. Number one, you could get both sides written as ratios and then cross multiply each other, and that's fine. Neither one of these is better than the other one. It really just depends on the situation. Or you could solve by multiplying by the least common multiple of the denominator. It's kind of what we did up here. Then create an equation using the numerators. Once there's variables involved and you're solving for them, check to make sure that, or check for extraneous solutions. So now that we have an equation involved, we got an equal sign here. We're going to do a little bit extra steps versus what we did upstairs here. We don't have anything to solve for, so there's nothing. A can't equal anything in these, or B, because there's nothing that equals. But here we do have some equal signs. So get both sides written as ratios. So this side right here it's not written as one big ratio. So what I need to do, right now this is over 1. Well, if I want it to be over x, I need to multiply by x over x. So it'd be x squared plus 3 over x is going to equal 4, and I'll put that over 1. Now, set cross products equal. So 4 times x equals x squared plus 3. And just like any other quadratic, get everything on one side. So x squared minus 4x plus 3 is going to equal 0. This would factor into, let's see, negative 3 and negative 1. So x equals a positive 3 and a positive 1. You do want to make sure, you want to plug it back in and make sure that nothing makes the denominators equal 0. So like here's an x in the denominator. If that's a 0, this can't be calculated. Now if I plug in 3, that's 1. 3 divided by 3 is 1. If I plug in 1, it's 3. So it's okay. That one works fine. So these are both solutions. Sometimes you get solutions that make the bottoms equal 0. You gotta throw them out. You gotta say those are extraneous solutions. You can't do them. This guy here, I got a ratio on the right side, but not the left side. Okay, so put this over 1, and now set cross products equal. So 15 times 1 is 15. X plus 2 times x would be x squared plus 2x. Again, bring that 15 over. And now do some factoring. And this would be plus 5 minus 3. So x is negative 5 and positive 3. I'll double check if I plug it in for the x's up here, does it make something undefined? And it's fine. If I plug it in here, I can divide by negative 5, and I can divide by 3, and it's okay. Everything works out fine. Now on this side, we're going to go about this route. We're going to do it this way. We're going to solve by multiplying by the least common multiple of the denominator. So what is the least common multiple? What's important, x plus 5 and then x minus 2, those would be factors. And then let's check to see what this one is. So if I factor this out, it is plus 5 minus 2. So it looks like the least common multiple or denominator, we can call it either one, least common denominator is x plus 5 times x minus 2. So I want to multiply everything by that. Okay, so I'm going to take this whole equation by x plus 5 times x minus 2. So if I distribute it all out, this first one, when I multiplied by x plus 5, on top and bottom it would cancel out, and I have a 3x times x minus 2. Plus, the second one, the x minus 2 would cancel out, and I'd have 1 times x plus 5. Equals, and now when I multiply this one, they both get canceled out, so it would just be 7 on the right side. So when it's an equation like this, the denominator goes away. So it's gone, and now I'm going to solve. So 3x squared minus 6x plus 5 equals 7. I'm going to work on getting everything on one side here too. So 3x squared, so negative 6x plus 5x would be negative 5x, and if I bring that 7 over, it would be minus 2 equals 0. If I factor this guy, 3x and x, then on this one, two numbers multiply give me negative 2. I just happen to know that this is a plus 1 and a minus 2. You would have to guess and check on that, but I'm saving some time and just doing it. So x equals, over here it'd be a negative 1 over 3, and over here it'd be a positive 2. Now we can't just automatically say, perfect, we like both those answers, because if I plug 2 in to the original equation, if I plug 2 in here and 2 in here, that's fine. That'd be 6 divided by 7. But if I plug in 2 right here, that's 1 divided by 0, because 2 minus 2 is 0. So 2 gives me an undefined answer. It doesn't exist. Now, negative 1/3, if I plug negative 1/3 in here, we're good. And because these are the factors, it's going to be good there too. So I'll get a number, not 0. So a non-zero number. Next one, so least common multiples here. Let's factor this just to see what the factors of that are. And it looks like the least common multiple of all of these would be, I'll just go like this, least common multiple will be x times x plus 2. So if I distribute this out, if I multiply the first expression, the x's will cancel out. It'll be x minus 3 times x plus 2 plus, And here the x plus 2's cancel out, so it'd be 3x, equals, that completely cancels out, so it'd be negative 6. So just foiling here, so x squared, and then plus 2x minus 3x be negative x, minus 6 plus 3x. I'll bring that 6 over as a plus 6, so set it equal to 0. So x squared, let's see, plus 2x, and that'd be it, right? And then equals 0, so x times x plus 2. So x would equal 0 or negative 2. And hopefully, seeing this already up here, that's kind of a red flag, because if I plug 0 in, if I plug it in here or here, that denominator is 0, so 0 is out. If I plug in negative 2 here or here, I get 0, so they're both out. So this actually has no solution. There is no number you can plug in for x to make this balance out. Now, applications. This is supposed to be written on the next page, so flip it over, and here's applications. Let's find the dimensions of a rectangle with a minimum perimeter if its area is 400 square meters. So I can change the shape of this, wider, skinnier, taller, whatever you want to say, but the area must maintain or must stay 400 square meters. So first, let's do some labeling here. We'll say length and width. So first off, the area, so the area would equal length times width. The perimeter would equal 2 length plus 2 width. But to solve this, if I want to minimize this, I've got to get them combined. I would love to have, I want to minimize perimeter. So I'm going to have to I'm going to use this one. So P equals, this is like my Y value. When I go to graph it, that's going to be my Y value. But I can't have two variables. I need one variable. So either L's or W's. So just find the dimension. So I can go either way. So using this guy here, let's solve for one of these. Okay, so I'll just say let's divide by W. So I got L by itself. L equals area divided by W. Well, in this case, area is 400. So the length is going to equal 400 divided by the width. Plug that in for the L over here. So this, I could call this P with respect to L. With respect to W, because I'm going to be plugging in for L. So the perimeter with respect to the width is going to equal 2 times 400 over W, plugging that in for L, plus 2 times W. So the perimeter is being written with respect to W. Do some simplifying here. So the perimeter with respect to the width, this would be 800 over x plus 2x. And I'm trying to minimize this, so I'm going to use my calculator. So let's go to y equals on this guy and type in this function I just put here. And so I type that in, and I'm going to hit graph. Try to remember what all this means. So the y-axis on this one is the perimeter. The x-axis is the width. Nothing shows up, and that's okay. That means I'm not zoomed out far enough to find this. So I'm going to zoom, and I think zoom fit. Zoom fit is always kind of a good one to see things well. And I really want to find the minimum here. And it kind of looks like, if you notice, the x-axis is not very spaced out, and the y-axis is jammed together here. I'm going to go to my window and see what's going on here, because it looks like there is no minimum. It looks like it just keeps going down forever, and it follows this asymptote. So if I go to my window, I'm only getting x values up to 10. I don't even need negatives, so I'm going to get rid of that. Now, what is the most, and this is kind of like infinity is the most, the widest, or I should say the widest this could be. But if you're thinking, if we did like a 400 by 1 rectangle, that would probably be, you could do an 800 by 1/2, and we could keep going all day, but kind of just want to get an idea of what's going on. I think my reasonable domain would maybe go up to about 400. Again, it does go up to forever, but so I'm going to change it to 400 and see what happens. When I graph it, notice it does start coming back up. So it looks like it does have a minimum somewhere over here. It's just that our original screen was only zooming into this far, so it wasn't seeing this. And you could probably do it from this screen, do a second calc, and we're going to try to find a minimum value. let's say if I go over here, in fact, I might just do like 0. And then a right bound, somewhere in here, it's starting to increase for sure. And then a guess, somewhere in there, it really doesn't matter for the guess. And it looks like the minimum value is 20 when y equals 80. So, I'm sorry, the minimum value is 80 when the width is 20. So minimum of 80 when the width equals 20. So if the width was 20, well, what would if this was 20, what would the length have to be? Well, it's going to be 400 divided by 20, so it's also going to be 20. Okay, so that's the minimum perimeter as if it was a square. That's going to give you the minimum perimeter. Steward cannery packages tomato juice in 2-liter cylindrical cans. Find the radius and height of the cans if the cans have a surface area of 1,000 square centimeters. So remember, we kind of do the same thing. We want to have it all in terms of, or in one equation. So one thing and plug stuff in to eliminate, so we have like just 2 variables total is kind of the goal. So first off, they have 2 liters is your volume, and then 100 square centimeters is your surface area. Well, 2 liters equals 2,000 square centimeters. I'm sorry, yeah, square centimeters. So let's kind of get them in the same, or sorry, cubic centimeters. Yeah, just so we have centimeters here instead of, we got liters and centimeters, 2 different units there. So the surface area is 1,000, so I'm going to plug in 1,000 equals 2 pi r squared plus 2 pi r h, and then the volume is 2,000, and this is square centimeters as cubic centimeters, pi r squared h. And I'd like to have these all in one. I want one equation, so I got to combine them. And one thing they have in common here, they both have an h that I can isolate. There's r and r squared. It's going to be difficult to do. You could solve for r here and plug it in for that r and that r, but that gets ugly. I'm going to solve for this r. So if I get that, I'm sorry, for this h. So if I get that h by itself, that'd be 2,000 divided by pi r squared, and then I can plug that in, and I'll have it all one big equation here. So I'll have 1,000 equals 2 pi r squared plus 2 pi r times 2,000 over pi r squared. Again, just plugging this in for h. And do some canceling. So this pi cancels out one of those pi's. Now this r cancels out one of the r's, so there's still an r on bottom. So I got 1,000 equals 2 pi r squared plus, and this would be 2 times 2,000 is 4,000 over r. I'm going to try to get rid of all the denominators here and make it a nice clean function. So I'm going to multiply everything by the least common multiple of the denominator. So that's r. So this would be 1,000 r plus 2 pi r cubed plus 4,000. And bring this guy over. So 0 equals 2 pi r cubed. I'm going to put this one next, minus 1,000 r plus 4,000. And I can use my calculator. I could graph this and look for the zeros on this guy. Okay, so move this out of the way. I'm going to hit graph here. Now I'm still stuck in my last screen that I had. So let's go zoom. Still graphing. So zoom. Again, we can go to zoom fit. See if that helps us see what's going on here. And not too bad, but I don't like that. I'm just going to go zoom. Let's see. Zoom standard. I'll go to zoom standard, see if I can see what's going on. Okay, it looks like it has 2 zeros, and they're both positive. So, and we're solving for r here. We're looking for what r equals. As long as r is positive, it's a reasonable answer. So it looks like there's 2 different radii that this could be. One of them, I'll go second calc, 0, again, going through the steps again here. It's going to be very difficult to get that cursor to stay on the screen. I know that the answer is between 1, 2, 3, it's between 4 and 5. So I'm going to get a left bound of 4 and a right bound of 5. And then a guess, I'll just say 4.5, somewhere in the middle. So 4.6, let's say 19. Or r could equal, again, the other one, 5, 6, 7, 8, 9, it's between 9 and 10. So I'm going to go second calc, left bound 9, right bound 10. Again, this is going to be way faster than trying to find the cursor on the screen and get it to line up. It's going to jump off the screen every time. So the 0 is 9.655. Oops, off the screen here. So let's see, find the radius and height. So if the radius was this, if I plug it in there, okay, then the height, we'll say, and if the radius is this, the height would be 29.839. If the radius was 9.655, then the height would have to be 6.829. So there's two different pairs of radiuses, radii, and heights that would make this work.